Welcome back, everybody. In our next section, we're going to go through a brief review of MPLS Layer 3 VPNs, make sure we understand how the unicast forwarding works before we can talk about the multicast forwarding. Now, in our current example, we have 4 provider edge routers that are XR1, router 1 on the left, and XR3 and router 3 on the right. Now, the goal is that we have 4 different customer sites that we're trying to establish unicast reachability towards. So let's talk about what are the components that make up this solution, and then how is this going to potentially affect our multicast design. Okay, so the first thing that we have is, actually let me take a step back. Let's label what are the device roles. Okay, so we have the provider edge routers, which are XR1 and XR3, and then on the bottom we have router 1 and router 3, which would make the devices connected to them the customer edge. So router 4 is the customer edge, router 5 is customer edge, 9 is CE, and 7 is CE. Now, the ultimate goal is that we have some sort of route advertisement coming in, and we need to receive this on the MPLS network, and we need to pop this out on the other side. Okay, so router 9 is going to have to know, how do I get to 8888/32, which is the loopback interface of router 8. Okay, so first off, we're going to be running between the provider edge and the CE, we're going to be running some sort of PE to CE routing protocol. In this example, we are running OSPF version 2 for IPv4, and then we're running OSPF version 3 for IPv6. In our case here, this course is focusing on IPv4 multicast only, not on IPv6 multicast. Okay, so we have OSPF that's running between router 4 and XR1, but the issue is we cannot run the same internal OSPF process, so we're not going to be redistributing between OSPF and OSPF, the customer and the provider. So we need to have some sort of overlay protocol. Specifically, this overlay protocol across MPLS is going to be BGP. So it's BGP VPN version 4, or in the case we're running IPv6, it would be VPN version 6. So the idea is we advertise the route from the customer to the provider. The provider somehow distributes this to all of the other provider edge routers that are within that VPN, and then it gets translated back into a customer route. Now, ultimately, the main thing that we're going to be focusing on here is the key point of the BGP next hop value that we're advertising into the provider network. Okay, so first off, let's test connectivity, make sure that this is just working from a unicast point of view. So from router 9, let's look at the routing table and say, do we have a route to 8888? Okay, which we do. And can we ping to 8888 when we're sourcing our packets from 9999? So loopback to loopback, okay, which we actually can't. Let's see, I think maybe in this config, I forgot to advertise router 9's loopback. Let's show run interface loopback 0, which that is the case. Okay, let's say show run include OSPF. Do show run. This is OSPF process 10, and we're running area 2. So we're going to go to the loopback IP OSPF 10 area 2. Okay, if we now go over to router 8, and let's see, do we have that route? Show IP route 9999. Yes, we do. Okay, it was updated just 10 seconds ago, so that's a new advertisement. So from router 9, can we ping 8, source from 9999? Yes, we can. Okay, if we do a trace route here, we should see that once the traffic goes into the provider network, it's going over MPLS labels, which is needed because the P routers, the devices in the very middle, which are router 2 and XR2, they don't have a route to any of these final destinations. So we're essentially hopping over them, or MPLS tunneling over them, by using that combination of the PE to CE routing protocol plus BGP VPN v4 based on the next hop of BGP in the core, and then also based on the MPLS labels. So in our particular case here, we see 2 label values that were used, 21 and 24,007, where the first of this is going to be the transport label that is normally generated via LDP. And then the next one is the VPN label that's going to be advertised through VPN version 4 BGP. So router 9 is going from the right to the left. It enters the provider network on XR3. XR3 is pushing or imposing 2 labels onto the stack. Okay, we could see this on XR3 if we looked at the show BGP VPN v4 unicast, and then we want to look for the specific destination we're trying to reach, which is 8888. So for 8888/32, and we need to say for the route distinguisher. Okay, route distinguisher is that value. Prefix is 8888/32. Okay, what we're specifically looking for here is what is the label value that we're using. Okay, receive label value in this case is 24,007. Okay, so just like we saw from the traceroute output, this is where that particular label value is coming from. And this is the VPN label saying that once you get to the last hop, this is how the last hop is going to figure out that, hey, the packet needs to go this way, as opposed to some other customer that might be connected on a different interface. Okay, also what this allows us to do is overlapping addressing between multiple customers. So it would be very common to have multiple CEs that behind them they have the 10 network. We need some way to keep track of those. If one customer has 10.110/24, the other one has the same 10.110, the way that we're keeping track of that is based on the label numbers. Okay, so this is where that 24,007 was coming from. The second label that we saw on the top of the stack, again, was the transport label. This is what XR3 would see when it's going towards whatever the next hop is. So we look at the BGP update. It says here's the best route. And to get there, we need to use the next hop 11, 11, 11, 11. So if we simply look in the show MPLS forwarding table, it says, well, how do we get to router 11? There's 2 different ways. We could switch out this port with label number 21, or we could switch out this port with label number 24,004. So assuming that router 9 sends a couple different trace routes, we should see that this bounces back and forth between label number 21 and then whatever the alternate one is. We may need to vary what the source and the destination is, because that's part of the hash, the 5-tuple of how it determines what label value to impose. So since we're tracing from 9999 to 8888 over and over and over, it's probably going to be stuck on label number 21. But the point being here, this is how we connect the unicast forwarding of the MPLS Layer 3 VPN, where the underlying transport label is going to be coming from typically LDP, and the overlay network is going to be coming from, or the overlay network label is going to be coming from BGP VPN version 4.